Greetings 11 Max 1 champions at South Sydney High School. This lesson is on division of polynomials, and division of polynomials uses kind of a long division algorithm or a long division approach, and so I wanted to make a video that you could look again at how we go about things. To give you an idea of division of polynomials, I thought I'd just construct a simple polynomial where I've got two factors, x minus 2 and 3x minus 7. I multiply them together, and you could cross multiply, expand the brackets. It's 3x squared minus 13x plus 14. So if I took 3x squared minus 13x plus 14 and divided by x minus 2, because of the way it's constructed, you'd expect to get 3x minus 7. And similarly, if I divide by 3x minus 7, you'd expect to get x minus 2. So we'll go through the approach. How do you go about dividing polynomials? But before we do that, I just wanted to remind you of the long division approach when we're dividing numbers, which is essentially to target, if you like, the largest factor of 10 or the largest side. Let's just do this: 5715 divided by 48, and we can set up our sort of, if I go 5715, then I put my long division brackets, however you do this, and we kind of target the highest powers of 10, and we'll go, let's say, 100 times 48, 4800, targeting the thousands, and then we subtract, and we keep subtracting multiples of 48 until we get, and 57 minus 48 is 9, until we get to either 0 or something less than 48 that we can't subtract anymore. Okay, next time we're going to use 480, it's 10, and 5 minus 0 is 5. We can borrow 1 across here. 11 minus 8 is 3, and 8 minus 4 is 4, 435. And we can't subtract multiples of 10 anymore. Let's just have a look at this. If I did go 10, it would be 480. It's too big. If I take off 48 from that, that gives me 432. Look at that. It's just 440 less 8, 432. 432, and that's, by the way, plus 9. And we've got 3 remainder. So the answer is 119 and 3 remainder, or 3 on 48. Okay, so let's have a look at an example of a polynomial and division. And I'm going to construct this polynomial so that we can see how the polynomial's constructed, and then we know what the answer is just for this illustration. So I'm going to take px equals x minus 2 times 3x minus 7 times x squared minus 1. And I'll start by multiplying these two terms, and you can cross multiply 3x cubed minus 3x minus 7x squared and plus 7. And I have done the multiplication. You could similarly cross multiply and collect like terms, but the px, the resultant px, is 3x to the 4 minus 13x cubed plus 11x squared plus 13x minus 14 plus 13x minus 14. So if I took that px and divided by x minus 2, you'd expect to get this polynomial here, 3x cubed minus 3x, and so on. Let's have a look at that, and we're going to use that same idea, the long division, where we're targeting the highest term and we're subtracting until we can't subtract any more multiples of x minus 2, and either you have 0 or you have a remainder. In this case, we know we're going to have 0 because x minus 2 divides exactly into that polynomial. So here we go. We've got 3x to the 4 minus 13x cubed plus 11x squared plus 13x minus 14. I'm going to put the long division sign in there, or the long division bracket, and divide by x minus 2. And I'm targeting, however you do your long division, it'll come out in a similar way. So I'm targeting that 3x to the 4. I'm going to multiply by 3x cubed. And let's do the calculation here in green on the side. I've got 3x cubed times x minus 2. That gives me 3x to the 4 minus 6x squared. So let's put that one in. 3x to the 4 minus 6x squared, minus 6x cubed, I should say, minus 6x cubed. And let's bring that down. The leading term is eliminated. Minus 13 minus 6, so that's adding 6, minus 13 plus 6 is minus 7x cubed plus 11x squared. We've got zeros here, plus 13x minus 14. Next, I want to target the minus 7x cubed, so I'm going to multiply by minus 7x squared. Minus 7x squared. Let me do that in a different color now. Let's pick amber here, and we go minus 7x squared times x minus 2, and that gives me minus 7x cubed to eliminate that leading term, and then plus 14x squared, plus 14x squared minus 7x squared times minus 2. So minus 7x cubed plus 14x squared, and we'll bring that down back to the blue. We've got 11 minus 14 minus 3x squared plus 13x minus 14, and next term you can see is going to be minus 3x. I'll do that this time. What have we got left? We'll try a turquoise. We've got minus 3x times x minus 2. Minus 3x times x minus 2, and that gives us minus 3x squared plus 6x plus 6x. Minus 3x squared plus 6x, bringing that down. 13 minus 6 is 7x minus 14. And you can see that the next term that I'm going to target, the 7x, I'm going to multiply by 7, and I'll still do the calculation. I've got one more color left to select, and we'll go for purple. So we've got, just to finish off that calculation, 7 times x minus 2 equals 7x minus 14. I put down 7x minus 14, and that gives us 0 remainder, as we expect. 0 remainder. I'll just bring that up a little bit. 0 remainder. So when I divide px by x minus 2, I get 3x cubed. Let's put up that. 3x cubed minus 7x squared minus 3x plus 7.